second. So it's part of the recording. All right. It's lesson 5.3, vocabulary. So for slope, lowercase m represents slope, which is also known as rise over run, which is also known as delta y over delta x, where delta means the change in. Delta is the Greek letter. That's a Greek D, delta. So the change in, which if I write that out, the change in y's means I take two y values and I subtract them, and I take two x values and subtract them. And then another way of interpreting this is that when you're dealing with functions, y and f of x are interchangeable. So I could also say, instead of y2 minus y1, it's f of x2 minus f of x1. Okay, so these are different ways to all represent exactly the same thing, which is slope. Slope is a number, okay? It's a ratio. And so when we talk about rate of change, we are talking about slope. We're talking about a ratio, a number, that compares the change in y to the change in x. Change in y, the one that's circled in blue, to change in x. I like writing it this way. It's really concise. I like using notation. This is a lot easier to write than this. You can draw a little triangle and put a y there. It means you subtract the y values. Rise. So on this part of this big explanation of what slope is, rise over run. When you count slope, you have a visual picture. And you take any 2 points on that line, and you're counting how many units up and how many units over. That's rise. The rise is the difference in the y values, how much you rise. And then the run is how much you move horizontally. Okay, that's the difference in the x values. So slope is the ratio of rise to run for any 2 points on the line. So if you are given a line or you're given some points, all you need is 2 points to figure out the slope of a linear equation or a linear function. You may end up with a different looking slope depending on which 2 points you choose, but once you take that ratio that you figure out and you simplify it, like for example, maybe you end up with 2/4, or you end up with 4/8, or you end up with 1/2, 10/20. These are all the same value. They just don't look the same until you simplify the fraction, simplify the ratio. So we're looking at slope. Slope formula. Okay, this is something you have learned before in 8th grade. This is how you can find the slope of a line that passes through any 2 points. So you take any 2 points, and you can refer to them as x1, y1, x2, y2. And then you just substitute in. You subtract the y values, you subtract the x values. Now, it doesn't matter which ordered pair you want to make your first point and which one you want to make your second point. You're going to get the same answer. Right? The only thing that you have to be consistent on is the way that you line up the ordered pairs. So in this specific example on this slide, we have -3, 8 as one of the ordered pairs, 2, -11 as an ordered pair. All right, and so they've chosen to make this point, -3, 8, the first ordered pair, and the 2, -11, the second ordered pair. That's why the little subscripts are there with the 1s and the 2s. Now, when they plug them into the formula, you're replacing these values with what you have. y2 is -11. y1 is 8. x2 is 2. x1 is -3. Notice that the ordered pair that you had has now been stacked. Okay, the green 11 and the purple 2, the green -11 and the purple 2 are from the same ordered pair. The red 8 and the blue -3 are from the same ordered pair. That has to be true. This would work out exactly the same if I instead changed which one of these points was the first ordered pair and which one was the second ordered pair. It would still simplify when you're all done doing your calculations all the way out to -19 divided by 5. This is a ratio. This is a slope. This is a negative slope because a negative value is here, -19 over 5. So this line that passes through these points, it goes downhill as you move along the x-axis in the positive direction, you're headed downhill because it's negative m, it's slope. All right, so before I give you guys the student paced mode, we're going to go through and try this stuff. I'm going to kind of explain to you what you're going to be doing. So the first thing you're going to do is watch a video on slope formula, what I was just talking about. Next thing you're going to do is answer a question about using the slope formula. You have 2 points. What is the slope of the line that passes through the 2 points? Then you have another video on is it linear? Another video on keep it linear. And then you have a problem where you're going to identify the missing value in this table, which we did something like this in Delta Math, so that the table represents a linear equation, an equation of something that creates a straight line. You have another video on average rate of change. Another one on average rate of change. Actually, I think that's, no, yeah, they're different. Okay, so 2 different videos. One is rate of change from a graph, and the other is rate of change from a table. Okay, and then you have an interactive slide where it says, over which interval shows an average positive rate of change? So this coordinate plane isn't labeled as y and x, it's labeled as t for your x-axis. And instead of y, we have g of t, it's a function, okay? G of t instead of f of x, and t is here. So when you're looking at these intervals, the values of t, so what does the blue line look like between -3 and 0? You can find -3 on the t and see where the blue line is, and then go to 0 and see where the blue line is. Does this show a positive rate of change? You're going to find which one shows the positive rate of change. Describing functions. So, you know, if you're looking at a graph, and I have all these colored letters sections over here, okay, if you have something that looks like section A, well, that's slowly increasing at a constant rate. If you have something that looks like B, this blue section, well, this is also increasing at a constant rate, but much more quickly. So this is quickly because it's steeper, okay? So when your slope is steep, it increases more quickly. Now C, the green part here, we're no longer increasing, we're decreasing. And it's a slow decrease. Part D, the black line, is still decreasing, but much more quickly. So it's a quickly decreasing segment at constant rate. For E, notice now we have a curve. Okay, this is no longer a straight line. It is no longer a constant rate. For it to be a constant rate, it has to be a linear section, a linear line, linear function, linear equation. But if it's curved, like we have here with E, this orange section, this is increasing because it is going uphill, but because it's curving more and more and more, it's increasing. The rate is getting quicker. So it could be like a car that's speeding up and going quicker and quicker, more quickly, instead of like a car that is in section A, just slowly increasing at a constant rate, where it's like the speed is going up, but it's not accelerating. If that makes sense. And then the last section you have with a little picture is the purple section F. It's flat, it's horizontal. If you remember about slope, when you have a line that's flat or horizontal, the slope is 0. Okay, it's staying the same. There is no change, but it is constant. It's constantly being the same over time. So, you know, maybe you're in a vehicle and you're at a stop sign. Time keeps moving. Your speed isn't changing. You're just sitting there. Nothing's happening. Okay, and then this last slide here is the shown function in the picture, in the graph. Is it increasing or decreasing? That's a simple multiple choice. All right, I'm going to put you on student paste. Okay, I'm going to go back to where you should start at, which is slide 4, slope formula. Okay, so watch this video and then you're going to try some of these problems. I'm going to give you feedback by going through what you're doing and marking the stars when you get it correct, okay? If you have any questions, I am available on chat in the Meet. But you have until 12:20. I'm giving you 20 minutes to work on this. Okay, so you should be in your Pear Deck tab for the next 20 minutes, watching videos, answering questions, and trying your best on this. Okay, so you're going to want to wrap up whatever question you're on or video you're on. And then come back to our meet. Okay, I'm going to switch it back over to, well, I get teacher paste, so I'm going to stop the student paste here at 12:20. Okay, so what I would like you to do right now is come back to our Google Meet tab, and I'm going to go over the answers with you. So the little star marking thing, like, I thought that was really cool. I could tell you if you got it correct or not, but then I'm realizing there's no way for you to tell if you got a star or not. It's like just for my benefit, which I don't see the point in that. So we're going to go over every problem that you guys had to do, and we're going to start with the one that's being presented right now in the meet. So if you're not in the meet, come back to the meet. And we have two ordered pairs. We have -9, 6 and -6, -9. And to find the slope that passes through these 2 points, I'm just going to use the slope formula. Okay, so slope is rise over run. Slope is the change in y over the change in x. And I'm going to share this tab with you, which is a whiteboard where I have it written out. It's a Jamboard. It's linked in the Google Meet as well. If you wanted to take another look at it after it's not on here, you can just watch the video later and pause it. But what we're going to do is figure out which ordered pair we want to be our first ordered pair, which one we want to be our second ordered pair. So it doesn't matter. I'm just going to make this one x1, and ooh, I'm using the wrong color. So let's just make this y2, x2, and y2, since I'm already on blue. And then we're going to make this one x1 and y1. All right. So once you have identified what you're plugging in, sometimes it's helpful to put in your subtraction signs before you plug in your values, because it's really easy to make a mistake when you're substituting in negatives and forget about your subtraction sign or forget about the negative. So it helps to put the subtraction signs in first. All right, and so I'm going to substitute in I didn't use the right colors when I'm coding this. I feel like I'm just confusing you guys. Let me back up. No, let me back up. So I apologize. Let me try this one more time, because I'm supposed to be trying to be consistent. I'm not even being consistent. Okay, here we go. Y2, Y1. Y2, Y1, right? See, I'm using the right colors now. And then x2, x1. All right, it doesn't matter which ordered pair is first or second. It could work either way. But now I'm going to substitute in, okay, y2 is 6, y1 is -9. x2 is -9. x1 is -6. All right, now when you have a subtraction sign next to a minus sign, it becomes adding the opposite, So it changes my value a little bit. And then to simplify this, well, 6 plus +9 is 15. -9 plus +6 is -3. This simplifies to the integer -5. All right, so the correct answer back here was C. C was the correct answer of -5. the video. Identify the missing value to make the table represent a linear equation. Show responses. 11 is the correct answer. 11 keeps us linear because we're repeating the pattern. 1 to 3, 3 to 5, 5 to 7, we're adding 2 each time. 5 to 7, 7 to 9, we're adding 2 each time. So 11 keeps it linear. Another video. Okay, which interval shows an average positive rate of change? So you have to kind of go through each one. -3 to 0. So -3 to 0. Look at the blue line. We're starting here, and then we go down. That is not positive rate of change. That is negative rate of change. So -7 to -4 maybe. -7 to -4. Here's where I start. Follow the blue line until I'm at -4. I still have an average negative rate of change. -9 to -5 maybe. Here's -9 to -5. Go up to the blue line, and I end up down here. Again, it's negative rate of change. So maybe it's the last one. It has to be because that's the only one I have left. 4 to 8. 4 to 8. 4, we start here, and we're following the blue line up. So we are having positive rate of change as an average from this point to this point. Okay, we are increasing ultimately. So D is the correct answer. For 13, and if you're using 12 to kind of help you, going back and forth and just toggling, this line is headed downhill, right? So it could be like C, or it could be like D, and C and D say slowly decreases at a constant rate or quickly decreases at a constant rate. So it's decreasing. The correct answer is decreasing. All right, so that is the end of that presentation. I'm going to turn it back on to Student Paste, and you can go back through and revisit and watch those videos, change your answers. But that's it. You have 4 more minutes in class, so I'm here for any of your questions, and if you don't have any, then you're free to go.